A very good morning. My name is Hamza Lubwama once again. And today I want us to share roots of quadratic equations. Good morning, everyone.
Good morning, teacher.
Today we have sum and the product of roots of a quadratic equation. Now, we have seen the general equation of a quadratic equation, how it looks like. We have realized that a quadratic equation is defined by ax squared plus bx plus c is equal to 0. And if that is the general format of a quadratic equation, if you let the roots of the quadratic equation to be alpha and beta, then it means x is either alpha or x is what? Beta. Just like you can have the two possible values of x. And if x is either alpha or beta, then it means that x minus alpha is equal to 0. Likewise, x minus beta is also equal to 0. But because it comes from quadratic equations, then it means that if you multiply these two factors, you must get 0. Now, if you multiply those two factors and you must get 0, because it comes just like you've been seeing that if you have, for example, if you recall, when you have x squared minus 5x plus 6 is equal to 0. Two numbers multiplied, you get 6, added, you get negative 5. Those two numbers are x squared minus 2x minus 3x plus 6 is 0. Then you get x into x minus 2 minus 3 into x minus 2 is 0. Then you'll see that x minus 2, when you multiply it with x minus 3, they give you 0. The idea of this equation was coming from that. So even this one, if these are the factors, then it means those two factors multiplied together, they also give you 0, because each of them is equated to 0. So furthermore, when we realize that, we can now go ahead. This was just a checkup to remind you of what happens when you have a quadratic equation. You will have x minus alpha, if you want to expand, and x minus beta is equal to 0. Then we shall realize x into x minus beta minus alpha into x minus beta is equal to 0. This will give us x squared minus x beta minus x alpha plus alpha beta is equal to 0. With this, you get x squared minus beta plus alpha times x plus alpha times beta is equal to 0. This we have derived is a general expression which predicts the sum and the product of the roots of a given equation. So with this, when you relate this equation, if you compare with the general quadratic equation, the general quadratic equations, the general quadratic equation says ax squared plus bx plus c is equal to 0. This one is saying x squared minus the sum of the roots times x plus the product of the roots gives us what? 0. When you check on this one, the coefficient is 1. So make sure this first equation also has a coefficient 1 by dividing everything by a. You'll get 0 out of a. You realize that you realize x squared plus b over a x plus c over a is equal to 0. Now, if I relate this equation star and this equation star 2, then you will see that the middle terms are, you will see that b over a is actually equal to a negative of alpha plus beta. Then c over a, you will see that is equal to the product of alpha and beta. But remember, these are roots. So this is the product of the roots. This is the sum of the roots. So what does it mean? It means that the sum of the roots is always equal to negative b over a, because I've taken this negative this way. Then the product of the roots is always going to be c over a. So we have been deriving this expression. The expression we have derived says x squared minus the sum of the roots times x plus the product of the roots is always equal to 0. So this is the general expression of quadratic equations that we have seen. And always, if the roots are alpha and beta, then any equation we are going to land on in our life, we should always know the middle term, which is the coefficient on linear x, is always equal to a negative b over a. Then the last term, which is the c is always the product of the roots of that quadratic what? Equation. Any questions here before we look at examples? So that is the definition for today. Yes, Namagembe Monica, you have a hand raised.
Okay, teacher, my question is on this part where you said b out of a is equal to negative alpha plus beta. I don't get why, okay, the negative is coming in. Yeah, yes, but then the lower one I understand, but then that part of putting there negative, is it a must that it has to be there, or it was?
Okay, I've got your question. Look at this one very carefully. Do you see this part?
Yes.
It is a positive, not so?
Yes.
In comparison, it is supposed to be equal to this part.
Oh, okay.
Which is a negative. That is why the alpha and beta times is equal to c over a. The one here is equal to the one where? There.
There.
You see that? So for that reason, the b over a is always equal to a negative. So ideally, the sum of the roots, the general equation is always supposed to be in the form x squared minus sum of the roots of x. Because if you say minus sum of the roots, when you go back, it means x squared minus the sum of the roots is a minus b over a of x plus c over a is equal to 0. When you simplify this, it takes you back to the final initial what? Equation. So always that sum is a negative b over a. So whenever there is a negative in the middle there, the sum is going to be a positive. Whenever the sum is a positive, we shall have a negative. They are going to interchange because of that negativity. But now you cannot understand them very well until I introduce an example. Okay? Let's look at examples. Take that screenshot, guys. Hope you're done. Examples. Form a quadratic equation for the roots below. A, -1 and -3. B, a quarter and 1/5. C, 3 and 5/2. So solutions. The first one, the roots are -1 and -3. Sum of the roots is what? -1 plus -3, and the answer is -4. Product of the roots is -1 times -3, and the answer is +3, right? Now, what does the equation state? The equation states that x squared minus sum of the roots times x plus the product of the roots is equal to 0. So we can create the equation by saying x squared minus sum of the roots of x plus the product of the what? Is always equal to what? To 0. So x squared minus the sum we have got, -4, close brackets, times x plus the product we have got, 3, should give us 0. Therefore, x squared plus 4x plus 3 is equal to 0. And thus, this is the equation we have designed as a result of having roots of that quadratic equation. Check it out with a calculator. Investigate and see, when you solve this quadratic equation, are the answers -1 and -3? Someone please confirm. Has someone pressed the calculator? All people don't know. If you don't know, let me train you and show you how to do it. Investigate with a curve. That is if you have fx 100 and above. Casio. Has anyone checked?
Yes, it's the same.
Okay. So part B. Part B, we have roots which are 1/4 and 1/5. So for part B, the sum of the roots is going to be what? Sum of the roots is 1/4 plus 1/5. And this is going to give us 9 out of 20. You cross multiply the 5 and the 4, and then you multiply it down by the 2. Product is going to be 1 out of 20. The general equation says x squared minus sum of the roots times x plus the product is equal to 0. This will give us x squared minus the sum, which is 9 out of 20, of x plus 1 out of 20 is equal to 0. With that reason, we can have 20 x squared minus 9 of x plus 1 is equal to 0. And thus, that is our equation. Any question here now? Teacher, show us how. Yes, Namagembe, do you have the FX91? What FX do you have?
Teacher, I have FX991.
Okay, press mode. When you press mode, tell me what you see.
I see compound complex.
Press
Comp
again.
1 and SD reg base
Press again.
equation.
Equation, eh?
Yes.
It's under 1, right?
Yes.
Press 1. What do you see?
Unknowns 2 and 3.
Unknowns 2 and 3. Those are simultaneous equations. Now, do you see a big button on your calc?
The one that's in the middle.
Yeah, with arrows.
Yes.
Press one of the arrows, either left or right.
Okay.
What does it say?
Degree.
Degree 2. This is a quadratic, so degree 2. The other one is a polynomial, degree 3. So go to degree 2.
Okay.
Has it brought A?
Yes.
A is the term on x squared. What is the coefficient on x squared? Here we have 20. Put 20. Then say equals.
Okay.
Has it brought B?
Yes.
Put -9. Yes, press equals again. Has it brought C?
Yes.
Press 1. Are you there? Then press equals. The answers must be 0.2 and 0.25.
Okay. Yeah. Yes. Thank you, teacher.
You can repeat it for this other one and see whether you get the same answer. Then this third one is yours. Everyone try out this one. Derive the equation for that last part. Yes, someone has an answer? Post.
Quadratic equation.
Hey, you want to give me the answer? If you go to 100, say it. What equation have you got?
Two x squared.
Huh?
2x squared
Mm-hmm.
minus 8x plus 15 equals to 0.
2x squared minus
8x plus 15 is equal to 0.
Any other person with something different?
2x squared sir,
Yeah.
may I have 2x squared
Mm.
minus 11x plus 15 is equal to
Plus 15
0.
is equal to 0. The other first one was what? The gentleman, give me your answer again.
Two x squared
Mm.
minus 8x
Mm.
plus 15 equal to 0.
Now, to know who is right, just investigate with 3. When you put there 3, see which one gives you 0. Let us put here 2 times 9, 18. 18 minus 11 times 3 is 33. 18 minus 33, you get negative 15. The 3 is correct. Satisfies. Let's check this one. 9 times 2 is 18. 18 minus 24. You get what? You get 6. This one is wrong. So this is the correct equation. So check out something. You must have missed out something in the middle. Okay? Have you seen your error? If I show it to you, it would have been x squared minus the sum, which is 3 plus 5 over 2 of x plus the product, which is 15 over 2. This is 6 plus 5, 11. So x squared. For you, added directly 3 plus 5. This is the same as 3 over 1. That's where your mistake is.
Yes.
Hope the rest you've also seen that. So since you are advancing, next time you don't need to write this. You should know in your head that always a quadratic equation has x squared minus the sum of the roots plus the product of the roots. Okay, now let us go to proofs, because they can set these numbers in terms of proofs. Expressions of alpha power n plus beta power n in terms of alpha plus beta and alpha times beta. The first one we are going to see is if I have alpha squared plus beta squared, how can I have this simplified? You recall from the expansion of alpha times beta plus beta squared, you get alpha squared plus 2 alpha beta plus beta squared. I hope everyone knows that expansion for that quadratic. Therefore, make alpha squared plus beta squared the subject. You'll get alpha plus beta, close brackets, squared, a minus twice alpha beta. This is a very sensitive expansion we shall need in these numbers. Another one is What if I have alpha minus beta? This is alpha squared minus 2 alpha beta plus beta squared. You'll see that alpha squared plus beta squared is the same as alpha minus beta squared plus 2 alpha beta. But this one may not help us in this line because it's a subtraction, yet we have been seeing the sum of the roots as sum of alpha plus beta. Another common expansion required is if you have alpha cubed plus beta cubed, it comes from expansion of alpha plus beta cubed. This is coming from alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus beta cubed. Right now, don't ask why this looks like this, because it comes from what we call Pasquale's triangle, which looks like this. We are just going to note it right now, but we shall have to derive it in future when we come to Pascal's triangle. So the 1 is the 1 here. The 3 is the 3 here. The 3 again is the 3 here. Then the last one is the 1 here. But the powers go on reducing. The first term reduces the powers from the highest degree of the power. The second one goes on gaining. So here you had b powers, beta power 0. But I don't want to talk much about that right now because I might confuse you when we have not yet discussed that. So let us just borrow from Pasquale's triangle to get this expansion. Okay. Or one can expand like a layman traditionally. Or I should expand using that one. Alpha plus beta cubed. Let me expand it for you, okay, as analogous students. Is alpha plus beta times alpha plus beta squared. Okay. We have already seen alpha plus beta squared, so we shall have alpha plus beta is the same as alpha squared plus 2 alpha beta plus beta squared. Alpha multiplies the whole of this bracket to realize alpha cubed plus 2 alpha squared beta plus alpha beta squared. Beta multiplies the whole of the equation plus alpha squared beta plus 2 alpha beta squared plus beta cubed. So this expansion is alpha cubed, this one and that one, plus 3 alpha squared beta plus 3 alpha beta squared plus beta cubed. So it can come from there. Now, what do we want? We want alpha cubed plus beta cubed. We make it the subject by saying it is alpha plus beta. The whole of this is cubed. Swale has poor network. Swale, where do you want to repeat? Minus 3 alpha squared beta minus 3 alpha beta squared. Swale, where is your problem? There is no problem. If you cannot see the problem, then I'll ask you to visit the YouTube later because I'm going to upload the video after this lesson.
From the equation.
Where? Which one?
The first one.
This one?
Yes.
And we are looking for alpha squared plus beta squared. Eh? So we decided to extract it from this expansion. By expanding alpha plus beta squared, you get these equations. Now, because you want alpha squared plus beta squared, add alpha squared to beta squared, and then take this one on the other hand. So it came up to this. This one is the same ideology with this one, but I said we should never use this because this one has a subtraction. Yet our sum of roots has an addition. That is the only way we can borrow from this. But just in case maybe something shows up differently, that's when maybe you can think about it. But rarely can we have a subtraction of the roots. Then I came to a point of getting alpha cubed plus beta cubed. I had showed people using this derivation, which comes from Pasquale's triangle, and I briefly talked about it here, but I said, okay, if Pasquale will confuse us right now, since we don't know it, let us expand like analog students, like 0-star students. We are not 5-star students anymore. We said split. You split alpha plus beta into alpha plus beta power 1 and alpha plus beta power 2 from indices. But we have already expanded alpha plus beta from here. When I substitute it there, I multiply by alpha first, I get this first expression. Then I multiply by beta again, I'll have this last part. Then we collect like terms of alpha cubed plus beta cubed. Then we take these two onto the other side. When they cross over, they become negativities. That's where we are. Swale, can I proceed now? Swale, again, he has gone off. Seems this network is funny. Okay, this one has not yet been concluded. Alpha cubed plus beta cubed will confirm alpha plus beta cubed, factorize out minus 3 alpha beta into beta plus alpha. You know, this is the sum, this is the product, this is also the sum. So it is in line with what we have been seeing earlier. So we can borrow these ideas and introduce sums and products. The last one I can talk about is maybe the expansion of alpha power 4 plus beta power 4. This one I will not expand. You'll investigate in your free time. Yeah? If I have alpha plus beta power 4, what does it give me? In your free time, expand alpha beta squared into alpha plus beta squared. If I over-expand right now, I will make you become lousy mathematicians. I want you to be active. So in your free time, you will check it out and investigate whether it gives us the following. If I was to follow Pascal's triangle, it would come to, after this one of 3, this is cubed. You come to 1, 4, 6, 4, 1. You go on summing 1, sum 1 and 3, 4. Sum 3 and 3, 6. Sum 3 and 4, 4. Always the last extreme value coefficient is 1. But because of not knowing Pascal's triangle, we are just quoting. So to quote this, we shall have alpha power 4. The alpha starts losing powers as beta gains, plus 4. Alpha loses 1 power to 3, beta gains power 1. Plus 6, alpha loses the second power to 2, and beta gains 2 now. Plus 4, alpha loses the third power, and beta gains 3 of them. Then lastly, beta gains all the maximum powers, which are 4. It is from here that now you see you have alpha power 4 plus beta power 4. When you make them the subject, you realize alpha plus beta power 4th minus, all these go over, minus 6 alpha squared, beta squared, that one is clear, plus 4 alpha minus 4 alpha cubed beta minus 4 alpha beta cubed. This condenses to alpha plus beta, which is a sum, which we have already seen, minus 6 of alpha beta, the product now squared, minus 4 of alpha beta into brackets, alpha squared plus beta squared. This one we have already seen the expansion. It is where? Where is it? Where is it? It is here. So you get this one and drop it there. Though my page is small. Alpha plus beta power 4. If it's a question, you do it side work, then you just substitute alpha plus beta times beta squared minus the product of alpha beta into big brackets, alpha plus beta squared minus 2 alpha beta. Now you see everything is in terms of the sum of the roots and the product of the roots. That is the intention of these expansions. They are trying to show you that you can simplify these expressions in terms of the sum and the roots of a given quadratic what? Equation. So this is just a highlight. an activation of your heads of how we shall simplify. But they cannot ask you to do this in quadratics. It's just the knowledge we are going to borrow in solving quadratics, especially the proofs, as I'm going to show you. Unless if someone has a question. If no one has a question, we are ready for examples in terms of this category of numbers. All right? So, next page, we can have examples. They can give you one quadratic equation that if alpha and beta are roots of a quadratic equation, x squared minus x minus 3 is 0, comma, find the values of Roman 1, alpha squared plus beta squared. Roman 2, alpha minus beta squared. Roman 3, alpha cubed plus beta cubed. Roman 4, 1 all over alpha plus 1 all over beta. Roman 5, 1 all over alpha squared plus 1 all over beta squared. Very good suicide example. It might take us the whole lesson if we don't. But it's good. It's talking about almost everything we have discussed before. Now, the first thing is to identify our equation as x squared minus 3x minus x minus 3 is equal to 0. When we have this equation, we can say 1, the sum of the roots, we let the sum of the roots be alpha plus beta. That is, if you let the roots, like they had said, the roots are alpha and beta, so the sum is alpha plus beta. But if the sum here is a negative, if the value in the equation is a negative, sir, is it alpha supposed to be used, or even other letters can be used? Other letters can be used, but the most common letters used in this category of math is alpha and beta. Is that clear? Just like you've seen other letters being used elsewhere. When they, in most equations, in most quadratic equations, we use x squared or x. But there are also quadratic equations of p. P squared minus p is 3. But learners, it is very convenient if you see x. You get my point? So even here, the convenience letters used are alpha and beta. You cannot have k and m. You cannot have p and q. They can be, but the most convenient ones are alpha and beta, as you shall see. Remember, I told you if this term on linear x has a negative, then the sum is going to be a negative of -1. But for those of you who cram, you just say it is +1 because it's a negative there. And you confirm this if there is also a 1 here. If there is no 1, you first divide and create a 1. Okay? Then the product of the roots. Product of the roots is alpha times beta, which is -3. Okay? So, why are we doing so? It's because the general equation says x squared minus sum of the roots times x plus the product of the roots must give us what? 0. Therefore, the first expression says alpha squared plus beta squared. We have already seen this one as alpha plus beta squared minus twice of alpha beta. When we substitute, what shall we realize? We shall realize a +1 squared minus 2 times -3. And our answer will become 1 plus 6, and the answer is 7. Hashtag solution. So the sum of the squares of those roots is 7. Case 2. Alpha minus beta squared. I told you this one, they set it in a funny way. They are not setting it as alpha squared minus beta squared. They are giving us alpha squared minus 2 alpha beta plus beta squared. You see, they are telling you that you now have alpha squared plus beta squared minus 2 alpha beta. But we have already realized this as 7. If we have already found that as 7, then it is comfortable to say alpha beta minus beta squared is equal to 7 minus 2 times negative 3. This will give me 7 plus 6. The answer is 13. The answer is what? 13. Check this out. Let me also introduce this one. It wasn't there, but let me call it Roman star. What if they brought alpha squared minus beta squared? You see, it's a difference of 2 what? 2 squares. Not so. It is the same as one saying, this is the sum. The sum we have already seen. Then you have always to think a lot. This one is the same as the square root of alpha minus beta squared. Indices above. So the sum is, remember what? The sum is 1, then the square root of 13, and the answer would be root of 13. So I have brought this because you never know. In this area, they set questions. Questions can come in a weird way, and it is your head to think outside the box and see how you can relate and create a relationship which satisfies what the question wants. If I can proceed, I saw Lutu with a hand. Yes, Lutu, please ask. Even there's some other people with questions. Please, you're also going to rally. Okay. Lutu first.
Teacher, if I repeat in Roman numeral 2. Yes.
Auntie, you know this expansion?
Yes.
It comes to this, right?
Yeah.
Now merge alpha squared and beta squared to come to this, okay? Minus 2 alpha beta, but alpha beta is the product. Which product is negative? 3. Then alpha squared plus beta squared, we have already seen it. If the question is only that and you had not found it before, find it. Okay? Yes?
Yes, teacher.
Yes, Swale. Swale also had a hand up.
Yeah, from the equation.
Which equation?
So,
here.
Roman 2. No, Roman 2.
Yeah.
When they give you the equation, you have to first expand.
You have to create the equation to be in the form of the sum and product of the roots. That is the technique of this area, or the definition of this area. That you have to express everything in terms of the sum and product. If you have already expressed an item in terms of sum and product, like alpha squared plus beta squared, and you've already got its answer, then you can borrow its answer and substitute. But if you do not know its answer yet, expand it further and get it in terms of alpha and, in terms of sum and product. Have I made myself clear?
Teacher, me, I'm confused.
Where exactly?
From the sum of the roots, how you got the sum of the roots and the product.
Okay. Can I erase this part here? Give me the general equation of a quadratic equation. What is the general equation of a quadratic equation? The lady who said she was confused.
X squared.
X squared
C equal to 0.
Do you agree?
Yes.
You divide by A, divide by A, divide by A, divide by A. X squared plus B over A of X plus C over A is what? Now, this is just the equation, not its roots. This is the equation in general. When we expanded its roots, let me take you back a little. When we expanded the roots, if the roots were alpha and beta, when we expanded and multiplied the two factors for the roots, the equation realized the following. Do you remember? Now, if it realized that equation, this is what is happening. It means here you have x squared minus the sum of the roots plus the product of the roots is equal to 0. Then when you confirm that for the roots and the general equation, then compare these two with their coefficients. It means negative alpha plus beta is equal to B over A. Then C over A is equal to, this is alpha beta, is equal to alpha times beta. So the elastic part is always the product, whether positive or negative. The middle part is always the sum. And we saw that the sum of the two roots is always alpha plus beta. Now, according to our equation, it was x squared minus x minus 3. The minus 3 is the product of alpha and beta. The negative 1 on x alone is equal to the negative of the sum of the roots, because the sum is supposed to be a negative of what is attached to x. That is why you see me here say alpha plus beta is a negative of what is attached to x. That is why I said it's negative, negative 1. But I said for those of you who cram, whenever it is a negative, just say the sum is a plus. Whenever it's a plus, the sum is a negative. But if you want to go into details and explain, maybe in a seminar or in a discussion, you have to go and give those details. So the lady, I don't know whether you're feeling better now.
Yes, teacher.
Can I proceed to the third example? The third example, it says alpha cubed plus beta cubed. You realize that we said it is the same as what? Alpha plus beta cubed minus 3 alpha beta into alpha plus beta. It is in terms of sum
Yes, sir.
and product. Yes, Swali.
So where does the square root come from in the second example?
On this one,
Yes.
Kakati now, on this one, I've told you they are going to set questions in a funny way. Funny way you've never imagined or seen. For example, they can set for you a cubed minus b cubed. Then you say, huh? Teacher only taught a cubed plus b cubed. Now, where is this one coming from? You have to bring out all your energy, all your knowledge, all your thinking of how we can simplify or expand that. That is why when we go ahead and discover Pascal's triangle, you should be able to reverse some of these items and see how always you can expand. Now, how the square root came in, I knew I have 2. But do you know that this 2 comes from the square root of 2 squared? That is now what they call thinking outside the box. And you as advanced level mathematicians, you should follow suit. You should also learn how to think outside the box. I think, Swale, because you missed indices. Indices are the same as those ones of O level, but we advanced a little. You should also visit my YouTube for those lessons and see them. So that is how I introduced the square root, sir. Okay? I think you can clearly see that this one can go back here. Why I introduced the square root is because I had already found a minus b squared. It was here. It was 13. I already knew it. So if I find the square root of that, I'm finding the square root of alpha minus beta squared. So this next number, you will see it is now in terms of sum and product. The sum is 1, so 1 cubed minus 3 into negative 3 into 1. This will give me 1 minus 9 plus 9, and the answer is 10. Number 4. 1 over alpha plus 1 over beta. LCM is alpha beta. Product has been realized. Divide by alpha, you get beta, plus divide by beta, you get alpha. The answer is sum over product. If it is sum over product, the sum is 1, the product is negativity of 3. Hashtag solution. Yeah? Are we good?
Yes, teacher.
Check out this one. 5. 1 all over alpha squared plus 1 all over beta squared. The LCM is alpha squared, beta squared. The cross multiplication becomes beta squared plus alpha squared. Learners can see that this is alpha plus beta, close brackets, squared minus 2 alpha beta, or is over the square of the products. This will give us, actually I've already found the numerator, which is 7 out of the denominator squared, which is going to be 9. Hashtag solution. Now, let me show you this weird one. Take a screenshot and let me know when you're done. So, if you've taken a screenshot, yes, Swali.
Yes, teacher.
Swali, your hand is up.
So, yes, sir.
Mm.
Now, on part 4,
Mm.
on part 3,
Mm.
there is alpha cubed plus beta cubed. So,
Plus the
I
expansion.
would like,
How I expanded.
yeah, how you expand it.
It came from here. Take this screenshot. It came from expanding this one. You realize this is what you're looking for plus that one. Then you take all these two to the other side. That's how it came up to this, and we simplified. Okay. Now, let me introduce this other one. Start to alpha cubed minus beta cubed. Very interesting. This is the same as alpha minus beta. Into alpha squared plus alpha beta plus beta squared. So if someone is handling such, sorry, this expansion, you look for it and see how, whether it comes up to that. You'll investigate it. You'll also investigate the other one. Also investigate this one. You'll also check out that. Now, me, I wanted to deal with this one because it has the weirdness. Alpha cubed minus beta cubed. We have seen that alpha minus beta is the square root of alpha minus beta what? Squared. I hope so now you know what I'm doing. Then the inside term will have alpha plus beta squared minus 2 alpha beta plus alpha beta. Then this will take me to root of alpha minus beta squared into alpha plus beta squared minus alpha beta. We have already found the square root. We have already found alpha minus beta squared, which is 13. So the square root here will be square root of 13. Into the sum is 1. The product is -3. The answer will give us 4 root of 13. So these are very two sensitive statements we need to have. Okay.
Excuse me, sir.
Yes, please.
So, how do I get to the YouTube chat?
How do we get there?
How do I get to the YouTube channel?
To the what?
To the channel that you told me.
Hey, just go to YouTube and subscribe to Wama Hamza. Okay.
Yes.
There's another equation here, guys. If the roots of the equation 3x squared minus x minus 6 is 0 are alpha and beta, evaluate. One over alpha plus 1 plus 1 over beta plus 1. 1 over alpha beta squared plus 1 over alpha squared beta. These ones will be yours. C, alpha cubed minus beta cubed. D, 1 over alpha squared plus 1 over beta squared. Now, I told you the equation has to have the coefficient on x squared as 1. So to start with, you should have the 3x squared minus x minus 6 is 0. First, divide everything by what? So that you have x squared minus a third x minus 2 is 0. Whereby the sum of the roots is going to be a third. I think you now know why I'm writing a third. Because the coefficient there was negative a third, sum of the roots is supposed to be negative of the term there. So the negative of negative a third is 1. Product of the roots is -2 as it is. Now 1 over alpha plus 1 plus 1 over beta plus 1 is equal to alpha plus 1 times beta plus 1 as the LCM, alpha plus beta plus 2. This will realize alpha plus beta plus 2 divided by alpha beta plus alpha plus beta plus 1. We are good to go and substitute to a third plus 2 all is over negativity of 2 plus a third plus 1. This will give me 7 all over 3. Then this will give me negative 1, which will give me negative 3, giving me over negative 2 out of 3. Thus, our answer is 7 out of 2. A negative. So you should be very good at simplifying functions. Part B is 1 over alpha beta squared plus 1 over beta alpha squared. The LCM is alpha squared beta squared. When I divide, I remain with alpha, I remain with beta. This gives me alpha plus beta out of the square. The sum is what? A third. Out of the product, which is negative 2 squared. The answer is 1 out of 12. Are we enjoying roots of quadratic equations? Unless if someone has a question. The rest are yours. So I'm going to stop here for now.
No, teacher, pardon the second last step.
How I introduce this one?
Yes, teacher.
And kakati alpha squared times beta squared is the same as alpha times beta, but the whole of it is what? Is that okay? So ideally it is the product squared. Yeah?
Yes, teacher.
Okay, so we can have that down.
Say question.
Hmm?
I did positive a third instead of negative a third.
How I got negative a third?
Positive a third.
How I got a positive a third?
Yes.
And kakati, you know that we derived this. This was negative a third. You see that?
Yes, sir.
The sum of the roots is supposed to be a negative of the coefficient on linear x. Yeah? Which is positive. That's why I was saying, in case it is mixing you just always have it in mind that if it's a negative term, then the sum is a positive. Whereas if it's a positive term in the middle, the sum is a negative. Okay?
Okay, sir.
So you go to Backhouse page, page today. Who has a Backhouse with them there? Tell us which page. Is it page 31? Someone with Backhouse 1, check on page 31. But let me send you numbers I have here as well, so that you can try them out. Okay? But also visit Backhouse 1. I'm also going to send some numbers from mastering here. There's a book of mastering A-level pure math, which we wrote, which I want you guys to have as well. Okay? Okay, with that, thank you for your attendance. And I pray that you understand these items and solve as many numbers as possible so that you become extraordinary students in the field of roots of quadratic equations. Any further questions concerning this, please don't hesitate to reach out to me in my inbox and you can get help from there. Some of you who came in late and you missed some of these tutorials, please visit my YouTube channel, Ruwama Hamza, and find some of these videos of the topics that we have covered so that you can be updated. In case you get a challenge, always get back to me and I see how I can help. The rest, you can leave at leisure. The rest, there is Maria, Monica. Monica, you had an example, a question I wanted to share with you last time. Let me answer your question before we leave. She asked me a question concerning trigonometry. And there was a line vector OP, which was changing from the different quadrants. And if this was theta, and the statement was saying, why is OP giving the same ratio when the angle subtended is the same? It is because as you move from this way, this is 0, this is positive 180. 0, positive 180, 0, positive 180, up to 360, 0, up to positive 180. Now, in this first quadrant, the sine of this angle theta, if it is sine of 30, for example, that answer is a half. Now, the corresponding angle here, which has the same ratio as this 30, because this angle is theta, the corresponding angle also here is theta. So before, if this is 30, before you reach 180, the angle here is 150. So sine of 150 is also the same as sine of 30. And that is the same as a half. It is page 180, page 180, 187, 188, Backhouse. You do the whole exercise. The challenges are what I will discuss for the next lesson, and we finalize this area. And some more ways of working from the roots back to equations. So please try out those numbers as much as possible. So back to Monica's question. Now, Monica, also when you come to this one, because this angle is theta, and we have assumed our theta is 30, how do I know that that angle is theta? It's because this angle here was theta. But also there is a definition of all students take cocaine, all students take coffee. Sine is positive here, and sine is positive here. Here sine is negative, here sine is negative. So this ratio here, when you add on the 30 from 180, when you arrive here, it will be 210. So sine of 210 is also a half. But because of these quadrant signs, it is a negative what? A half. So if you want it to become a positive, it should be negative sine. So it should be the same as negative sine of 210, which is the same as a negative sine of 180 plus any other angle. Then the last quadrant here has 0. If this is 30, how do I know that it's 30? Look at this second value here, where we saw theta. This value is theta. This one also would be theta. So if our theta was 30, then the angle here would be 330. Sine of 330, when you confirm with the calc, is also a negative a half. So, but this 330 is got by subtracting 30 from 360. So it's the same as saying it is a negative sine of 360 minus theta. Or it's a negative sine of 360 minus 30. All these give you the answer as a half. But the first thing is that the ratio is a half, then the sine bit comes in. The sine is predicted from the quadrants where you are, but all the ratios are a half at that position. So it is the same for all other angles. That if the angle was not 30 and the angle was 60, was 70, was 80, the condition is true for all other what? All other angles. I don't know whether Naminemba have managed to answer your question. Okay. Monica, are you there?
Yes, teacher.
Have I answered your question?
Yes.
Okay. Okay, guys, we have a nice day. So Backhouse, please. This is Backhouse 1. I also sent you PM. Go to also understanding pure mathematics. Understanding pure mathematics. All these are there. So go and try out these numbers on roots of quadratic equations. You will see how interesting they are if you're passing all of them. Okay, with that, we can have a good day. We meet in physics for those of us who offer physics after lunch.